Okay, so we are going to balance these three equations. These are chemical reactions. We have reactants on the left side yields the products on the right side. So the first one is C2H6 plus O2 yields H2O plus CO2. This equation is not balanced. So the first thing we want to do is underline the entire equation. We want to separate the reactants from the products. And we want to list the elements in a column. We have carbon, hydrogen, and oxygen. We always want to leave hydrogen and oxygen as the last two elements to balance. They often tend to balance themselves. Okay, so we're going to start with carbon, okay? On the reactant side, we have 2 atoms. On hydrogen, we have 6. Oxygen, we have 2. On the product side, carbon, we have 1. Hydrogen, we have 2. Oxygen, we have 1 plus 2, or 3. So we can start with balancing carbon. We can multiply this by 2, the carbon by 2. We can add a coefficient of 2 in front of CO2. So now we have 2 moles of carbon dioxide. Carbon is now balanced. However, this also affects the oxygen atoms, okay? So now we have 1 plus 4, or 5, on the product side, okay? So we want to move down now to hydrogen. So we have 6 and 2, okay? So we can multiply this by 3 to give us 6. We could put a 3 in front of H2O. And again, hydrogen is now balanced, but that again affects oxygen. So now we have 3 plus 4, or 7. So carbon is balanced, hydrogen is balanced, oxygen is not. And this is where it gets a little bit awkward, okay? Because 2 and 7, you're thinking, you're starting to get into fractions and multiplying both sides by numbers. But the simplest way to do this is we can take oxygen. 2, we can multiply this by 7 over 2, okay? So that gives us 14 over 2, or 7, all right? To balance, we could put 7 over 2 as a coefficient. However, it has to be a whole number. Okay, so the simplest thing to do now is to multiply this entire equation by 2. We now put a 2 as the coefficient in front of C2H6. That eliminates this 2 and keeps it at 7. Multiply this by 2 to get 6. Multiply this by 2 to get 4. This equation is now balanced. We're going to move on to number 2. KOH plus H3PO4 yields K3PO4 plus H2O. Again, we want to underline and separate. Now list our elements. We can start with K, which is potassium, P, phosphorus, H, O. K, P, H, O. Okay, so on our reactant side, we have 1 atom. Phosphorus, we have 1 atom again. Hydrogen, we have 1 plus 3, or 4, and oxygen, we have 1 plus 4, or 5. On our product side, potassium, we have 3. Phosphorus, we have 1. Hydrogen, we have 2. And oxygen, we have 4 plus 1, or 5. So we can start with balancing out potassium. Multiply this by 3. We put a 3 in front of KOH, okay? That also affects oxygen and hydrogen. So we can start with hydrogen, okay? So now we have 3 hydrogens plus 3 hydrogens here, or 6. And then oxygens, we have 3 plus 4, or 7. Okay, so potassium is balanced. Phosphorus happens to be balanced as well. Hydrogen, we have 6 on the reactant side, 2 here. So we could do this next. We can balance this out, multiply this by 3 to get 6. So where's hydrogen up here? We can put a 3 as a coefficient. Okay, 3 moles of H2O. So then that balances hydrogen, but then it also changes how many oxygen atoms there are. So here we have 4 plus 3, or 7. This equation is now balanced. We're going to move on to number 3. So we have SnO2 plus H2 yields Sn plus H2O. So Sn is tin. Okay, we have 1 atom of tin on the reactant side. Hydrogen, we have 2. Oxygen, we also have 2. On the product side, we have 1 atom of tin. Hydrogen, we have 2. Oxygen, we have 1. So we're going to start with oxygen, since that is not balanced. And we're going to multiply this by 2. So we can put 2 as a coefficient in front of H2O. So that gives us 2 moles of water. So that balances oxygen. However, again, this also impacts the hydrogen. So instead of 2, we now have 4 atoms of hydrogen. So now we can balance the hydrogen on the reactant side. We can multiply this by 2 to give us 4. And we can now put a coefficient of 2 in front of H2. This equation is now balanced.